Hello everyone, I'm Abhishek. This is the third part of some more special kind of integrals. Now today we will learn integration of rational function of sin x or cos x. That is the integration of the form a sin x plus b cos x plus c by p sin x plus q cos x plus r dx. So there are two cases. In the first case, when a and b are 0 but c not equals to 0, that means in the numerator only constant term will be there, and in the denominator p and q are not both 0. P and q can be 0 but together they cannot be 0, but r should not be equals to 0. That means the integrals will be of the form of either c by p sin x plus r, or c by q cos x plus r, or c by p sin x plus q cos x plus r. So in that case, how to integrate? So in this case, we will write sin x as 2 tan x by 2 by 1 plus tan square x by 2, and if it is cos x is there, then we will write cos x as 1 minus tan square x by 2 by 1 plus tan square x by 2, which is the formula of multiple and submultiple angle of trigonometric functions. Then we will put tan x by 2 as z. So let us see one example. So here we have the first example. This example is dx by 5 plus 4 cos x. So here sin x term is not there in the denominator, and in the numerator there is only one constant, that is 1. Now as I told that in case of cos x, I will write 1 minus tan square x by 2 by 1 plus tan square x by 2. So I replaced cos x by this. Then I will do the LCM. So if I do the LCM, it will be 5 plus 5 tan square x by 2 plus 4 minus 4 tan square x by 2 divided by 1 plus tan square x by 2. Now this 1 plus tan square x by 2 will go in the numerator, as there is a fraction in the denominator of the main expression. Now we can write this 1 plus tan square x by 2 as secant square x by 2, and we can put that secant square x by 2 in the numerator, so it will be secant square x by 2 dx by, now if we simplify this thing, it will be 5 plus 4 9. Now 5 tan square x by 2 minus 4 tan square x by 2, it will be plus tan square x by 2. Now as per the rule, we can consider this tan x by 2 as z. Now if we consider tan x by 2 as z, if we differentiate that, it will be secant square x by 2 by 2. Why by 2? Because there is x by 2 by using the chain rule. So dx will be dz. Now we can put the 2 there, so it will be secant square x by 2 dx equals to 2 dz. So therefore this secant square x by 2 dx will be replaced by 2 dz. So it will be 2 dz by this 9 plus tan square x by 2 will be replaced by 9 plus z square, as we considered tan x by 2 as z. So we have a formula. This is this 2 we can put outside. Now this is in the formula dz by a square plus x square. Now here a is equals to 3, so the formula is 1 by a tan inverse x by tan inverse z by 3. So therefore 1 by a is 3, so 2 by 3 into tan into tan inverse z by 3 plus c. Now here again, if we put the value of z, so therefore we have 2 by 3 tan inverse of tan x by 2 by 3 plus c. Now let us see the second example. In the second example, we can see that it is dx by 3 plus 2 sin x plus cos x. So here sin x and cos x, both terms are there in the denominator, and we can see in the numerator only constant is there, and the constant is 1. So as per the rule, we can write sin x as 2 tan x by 2 by 1 plus tan square x by 2. Now 2 is multiplied with sin x, so 2 into 2 will become 4. 4 tan x by 2 by 1 plus tan square x by 2, plus again cos x will be written as 1 minus tan square x by 2 by 1 plus tan square x by 2. Now what we will do the LCM here. So if I do the LCM, so denominator will be 1 plus tan square x by 2, and that denominator will go in the numerator of this actual expression. So therefore 1 plus tan square x by 2 is already there in the numerator. And what about this sum? The sum will become 3 plus 3 into tan square x by 2, then 4 tan x by 2 plus 4 tan x by 2, then plus 1 minus tan square x by 2. So plus 1 minus tan square x by 2. So we have done the LCM here. Now we need to simplify the denominator, and we will write 1 plus tan square x by 2 as secant square x by 2. So this is secant square x by 2 dx. Now if I simplify these terms, we can see it will be 3 tan square x by 2 minus tan square x by 2 will become 2 tan square x by 2, plus 4 tan x by 2, only one single term, so it will be as it is. Then 3 plus 1 will become 4. Now we can put tan x by 2 as z. So if I put tan x by 2 as z, we can see it will be 1 by 2 of secant square x by 2 dx equals to dz. So that means we need to adjust this 1 by 2, or you can put this 2 to that side. So here I have adjusted. So how I have adjusted? I have taken that 2 common from all these 3 terms. So if I take that 2 common, so it will be tan square x by 2 plus this will be 4 tan x by 2 will become 2 tan x by 2, and this 4 will become 2. So there will be a 2 in the denominator, and this 2, if I put it in the numerator, it will become 1 by 2 in the numerator. So 1 by 2 secant square x by 2 dx. Now 1 by 2 secant square x by 2 dx will become dz, and tan x by 2 will become z. So it will be z square plus 2z plus 2. Now I have written this 2 as 1 plus 1, because we know there is a formula that z square plus 2z plus 1 is z plus 1 whole square. So that means in the next step I am going to do this thing, make this thing as z plus 1 whole square plus 1. So it is integration of dz by z plus 1 whole square plus 1, which can be written as tan inverse of z plus 1 by 1 because by a, because here a is 1. So tan inverse of 1 by a, again 1 by a will become 1. So I have not written that 1. So tan inverse of z plus 1 by 1 plus c. So it will be tan inverse of tan x by 2 plus 1 plus c. Now the second case is to evaluate the integral of the form this, where a and b are not both 0. That means there should be some terms of sin x or cos x in the numerator along with constant. Constant can be equals to 0, there is no problem. So in this case what we have to do? In this case we will write the numerator as a into, here a is a constant, a into the denominator plus b into, b is another constant, that is differentiation of the denominator, differentiation of this denominator plus a constant c. So let us see how to solve questions of this form. So in this example 3 we can see there the integral is of the form cos x by 3 cos x minus 5. So here we can see the numerator is not a constant term. There is some terms of sin x or cos x. We can see there is a term of cos x, and the denominator is a combination of sin x cos x. In fact here sin x term is not there, that means the coefficient of sin x is 0. So now as per the rule, what should I do? I will write the numerator as a into a constant a into the denominator the denominator is 3 cos x minus 5 plus b, another constant, into differentiation of the denominator plus a constant c. So if I differentiate that, let's see what happens. If I differentiate that, it will be minus 3 sin x. This will be minus 3 sin x. So along with this b, it will become minus 3b sin x. So if we break these brackets, so we can write 3a cos x minus a into 5, 5a minus 5a, then plus b into the differentiation of this is minus 3 sin x, so it will be minus 3b sin x. Differentiation of the constant part is 0 plus c. Now I will write in terms of cos x in the combination of cos x and sin x. So it will be 3a cos x minus 3b sin x. Now all the constant terms together, so we can write plus c minus 5a. Now if we compare the terms, we can see in the LHS there is only one term of cos x. So that means 3a should be equals to the coefficient of the LHS, and the coefficient of the LHS is 1, so 3a should be equals to 1. Since there is a no term of sin x in the LHS, so that means that coefficient will be 0, that means minus 3b. The coefficient of sin x in RHS is minus 3b, so minus 3b will become 0. And since there is a no constant term in LHS, so therefore c minus 5a will also be 0. So from this we can find out a is equals to 1 by 3, b is equals to 0, and c is equals to 5 by 3. Now if I put the values of a and b and c in this relation, so cos x will be, the value of a is 1 by 3, value of b is 0, and value of c is 5 by 3. So we can replace this cos x by this expression. So what we can write, so it will be 1 by 3 into 3 cos x minus 5 plus this term will not be there because b is 0 plus 5 by 3. So therefore we can write this integral cos x by 3 cos x minus 5 dx as 1 by 3 into 3 cos x minus 5 plus 5 by 3 by 3 cos x minus 5 dx. So up to that it is done. Now we need to integrate that. Now for that I will distribute the denominator. So if I distribute the denominator with this term and this term separately, we can write this will be equals to 1 by 3 dx plus this equals to 5 by 3 by 3 cos x minus 5. Now this 5 by 3 will go outside of the integration because it is a constant term multiplied with this expression. So therefore we can write this. Now this integration is simple, it will be x by 3 plus 5 by 3. Now we can see this is integration where in the numerator there is nothing, only a constant term is there, and in the denominator there is a combination of sine, cos, and constant term is there. So we can as per the rule we can write cos x as 1 minus tan square x by 2 by 1 plus tan square x by 2. Since there is no term of sin x, so no need to replace sin x. So therefore if we write the value, so it will be 3 into 1 minus tan square x by 2. Now I will do the LCM. So if I do the LCM, there is a 1 plus tan square x by 2 in the denominator. So if I do the LCM, this 1 plus tan square x by 2 will be multiplied with this 5. So we can write this is minus 5 into 1 plus tan square x by 2. So in the denominator it will be 1 plus tan square x by 2. Now this is secant square x by 2 will go in the numerator. So therefore this will be secant square x by 2 dx divided by, now if I break the bracket or simplify this denominator, we can write 3 minus Now 3 minus 5, so I am writing the constants first. So there is a 3 into 1 3 minus 5 into 1 minus 5, then 3 into tan square x minus, so minus 3 tan square x by 2, then minus 5 into tan square x by 2, so minus 5 tan square x by 2. So we can write this thing as minus 2 minus, this is minus 8 tan square x by 2. So again what we will do, we will put tan x by 2 as z. So we know that if I put tan x by 2 as z, it will be 1 by 2 secant square x by 2 dx dz. So there is a 1 by 2 we need, so that 1 by 2 I will adjust from the denominator. So we can see in the denominator we can take common 2. So this 2 will go in the numerator and will become 1 by 2 secant square x by 2. So this is 1 by 2 secant square x by 2. Now in fact I have taken common minus also. So this minus is outside. So minus 5 by 3, it will make the coefficient negative. So it will be 1 plus 4 tan square x by 2. So now I will replace this. I will replace half secant square x by 2 dx as dz, and all the tan x by 2 will be converted to z. So that means we can write 1 plus 4 z square. So 1 plus 4 z square. Now here what we can do, we will take common 4. So if I take common 4, so 1 by 4 will go outside because this 4 is in the denominator. So when we will take common 4, it will go outside as 1 by 4. So there is a 1 by 4. Now if I take common, so it will be 1 by 4. If I take common 4 from these two terms, this term will become 1 by 4, and this 1 by 4 can be written as 1 by 2 whole square, and 4 is taken common. So therefore we can write this is z square. So therefore now it is in the form of dz by a square plus z square, and the formula is tan inverse 1 by a tan inverse z by a. Acha, I have done a mistake here. Okay, so I will show you what is a mistake here. So there is already 1 by 4. So this is this will be, so this 4 will be multiplied with 3, so it will be 5 by 12, and this will be 1 by a is 1 by 2, so 1 by 2, so 1 by 2 into tan inverse z by a. So there I have done the mistake. So it will become 2 tan inverse 2z. Now this 2 and 12 cancelled out, it will be 5 by 6 tan inverse. Now this will be 2z, so z is tan x by 2, so therefore 2 tan x by 2 plus c. So therefore the integration will be x by 3 minus 5 by 6 tan inverse of 2 tan x by 2 plus c. Now let us see the fourth example. It is given that integration of dx by 1 plus cot x. So here I will write the cot x as cos x by sin x. Then I will do the LCM. So if I do the LCM, then it will be sin x plus cos x by sin x. So this by sin x will go in the numerator. So it will be sin x dx by sin x plus cos x. Now again there is a sin x function in the numerator. So I have to apply the second condition. So second condition, according to the second condition, the rule is the numerator will be sin x will be equals to a into the denominator, that is sin x plus cos x, plus b into differentiation of the denominator. Now the differentiation of this denominator is cos x minus sin x, so that I have written here b into cos x minus sin x plus c. Now let us find out the coefficients of sin x. Let us arrange the terms. So here we can see a sin x minus b sin x. So that means we can take common sin x, so it will be a minus b sin x, then plus a plus b, so plus a plus b cos x into cos x plus sin x. So if I repeat again, so we can see sin x, if I take the sin x all together, then we can see the coefficient of sin x here will be a, and here the coefficient of sin x will be minus b. So therefore it will be a minus b into sin x. And if I see the coefficients of cos x, here the coefficient of cos x is plus a, and here the coefficient of cos x is plus b. So plus of a plus b cos x plus c. Now if I compare the terms, the sin x coefficient here is 1 and here is a minus b, so therefore a minus b is equals to 1. The cos x coefficient in the LHS is 0 and in the RHS is a plus b, so therefore a plus b is equals to 0, and since there is no constant terms in the LHS, so therefore c will become 0. Now after that we will solve the equation. Directly we can get here c equals to 0, so no problem. Now if I solve these two equations, we are getting to values of a and b. Value of a is 1 by 2 and value of b is minus 1 by 2. Let me tell you one more thing. If you see that there is no constant in the denominator, no constant in the numerator, so you can take c directly equals to 0, means no need to write this c. What I told, if you can see that there is no c, no constant term in the denominator and as well as in the numerator, so no need to take this c. So therefore we can write sin x as half of sin x plus cos x minus half of cos x minus sin x, and c is 0. So therefore I will replace this sin x with this expression and with the values of a and b. So we can write half of sin x plus cos x minus half of cos x minus sin x, c is not there, divided by sin x plus cos x dx. Now I will distribute the denominator. So if I distribute, first of all it will be cancelled out here with this term, so therefore it will be only half integration dx, and with this term we can write minus half is outside the integration, cos x minus sin x by sin x plus cos x. Now we can see this is in the form of f dash x by fx dx. Now if it is f dash x by fx dx, we know the formula is log of mod fx. So therefore we can integrate this and the integration will be log mod of the fx. Fx is sin x plus cos x. So log mod sin x plus cos x. Already there is a minus half here, so minus half, and this integration will be x, so it will be half x plus c. Now this is fifth example. Though it is not falling in this format, whatever I have given in that format, but still in this case also we can do the same thing as we do sin x as 2 tan x by 2 by 1 plus tan square x by 2, and cos x as 1 minus tan square x by 2 by 1 plus tan square x by 2. So the integration was 1 plus sin x by sin x into 1 plus cos x. So I will replace sin x by this and replace cos x by this. So wherever I get sin x, I will replace by 2 tan x by 2 by 1 plus tan square x by 2. So first of all I will do the LCM in the numerator, and also I will do the LCM in the denominator if possible. So therefore it will be 1 plus tan square x by 2 plus 2 tan x by 2 in the numerator by 1 plus tan square x by 2. So we have this LCM, and in the denominator we can see it will be 2 tan x by 2 by 1 plus tan square x by 2 into, now we can do the LCM here, so it will be 1 plus tan square x by 2 plus 1 minus tan square x by 2. If I do the LCM here, and in the denominator it will be 1 plus tan square x by 2. But here we can see that tan square x by 2 is cancelled out here, and we can also see that 1 plus tan square x by 2 is also cancelled here. So therefore we can write this thing as 1 plus tan x by 2 whole square, because it is in the form of that a square plus b square plus 2ab. So therefore it is tan x by 2 plus 1 whole square. Sorry, here 1 plus tan x by 2 whole square. And these 1 plus tan square x by 2 will go in the numerator and multiplied with this term. So it will be 1 plus tan square x by 2. Now here it will be only 2 left here, and there is also 2 tan x by 2. So therefore we can write 2 into 2 tan x by 2. Now we can make this 1 plus tan square x by 2 as secant square x by 2, and we are bringing 1 2 in the numerator, so it will be half secant square x by 2. So therefore in the denominator there will be only 1 2. So therefore it will be 1 plus tan x by 2 whole square into half secant square x by 2 by 2 tan x by 2. Now we can put tan x by 2 z. So if I put tan x by 2 z, we know that 1 by 2 secant square x by 2 dx will be dz. So therefore this term will be dz, and all the tan x by 2 will be converted to z. So therefore we can write this term as 1 plus z whole square, and this will be 2z, and these will be dz. Now here we can use a formula here. So it will be 1 plus 2z plus z square by 2z. So here what we can do, we can distribute this denominator. So if I distribute the denominator, it will be 1 by 2 z, 1 by 2 z, so 1 by 2 outside, so it is integration of dz by z. Here 2z cancelled out, so it will be only integration of dz, and here it will be 1 by 2 integration of z dz. Now we know that integration of that is log mod z, integration of that is z, and integration of this is z square by 2, and it will be 1 by 4 z square plus c. Now I will replace the value of z. So it will be 1 by 2 log mod tan x by 2 plus tan x by 2 plus 1 by 4 tan square x by 2 plus c. Now let us see the sixth example. It is given that 2 sin x plus 6 cos x by 3 sin x plus 4 cos x dx. So again in the numerator we can see it is a combination of sin x and cos x. So it is a second type of integral. So here I will apply the rule of that, and we will write the numerator as a multiplication of a into the denominator plus b into the differentiation of the denominator plus c. Now let me tell you here, since there is, as I told, since there is no c, so no constant term in both numerator and denominator, so you can skip this c also. You don't write c, because I will get the value of c is 0. Okay. So therefore 2 sin x plus 3 cos x will be equals to a into the denominator 3 sin x plus 4 cos x plus b into the differentiation of the denominator. Now if I differentiate that, it will be 3 cos x minus 4 sin x. So therefore let me arrange the terms. So if I arrange the term of sin x first, so let me see what is the coefficient of sin x. It is 3 here and a, so 3a, then next minus 4 here and b, so minus 4b, so 3a minus 4b is sin x. Again, what is the coefficient of cos x? A into 4, 4a plus 3b, 4a plus 3b cos x. So therefore if we compare the terms, we can see that 3a minus 4b will be equals to 2. So 3a minus 4b equals to 2, and 4a plus 3b will be equals to 3, as the coefficient of cos x is 3. Now if we solve this, so we will get the value of a as 18 by 25 and b as 1 by 25. I have shown the solution here, so I hope you can solve it. Now I means the integration will be, if I see the integration, so here I will replace the numerator by this expression with the value of a and b. So we can write 18 by 25 into 3 sin x plus 4 cos x plus 1 by 25 3 cos x minus 4 sin x. So therefore I can write 2 sin x plus 3 cos x as this: 18 by 25 3 sin x plus 4 cos x plus 1 by 25 3 cos x minus 4 sin x divided by 3 sin x plus 4 cos x. It was already there, 3 sin x plus 4 cos x in the denominator. So next I will distribute the denominator. So if I distribute the denominator, so first of all it will be cancelled out with this term. So it will be 18 by 25 dx, and here it will be 1 by 25 outside, then differentiation of the denominator by the denominator dx. That means it is of the form of f dash x by fx, and the integration of f dash x by fx is log mod fx. So here we have log mod 3 sin x plus 4 cos x with the coefficient 1 by 25, and here the integration of this term is 18x by 25 plus c. Now this one is the last example of today's video. So it is integration of 3 cos x plus 2 divided by sin x plus 2 cos x plus 3. Again it is the second type of integration. So therefore here I will write the numerator equals to a into the denominator plus b into the differentiation of the denominator plus c. I have to write here c because I can see that there is a constant term in both numerator and denominator. If you see constant in any one of that, you have to write c, but if there is no constant term in both numerator and denominator, no need to write c, because in that case c will be 0. So therefore 3 cos x plus 2 should be equals to a into the denominator, that is sin x plus 2 cos x plus 3, you can see here, and b into the differentiation of the denominator. Now the differentiation of this denominator will be cos x minus 2 sin x plus 0, that is cos x minus 2 sin x, cos x minus 2 sin x plus c. Now we need to arrange the terms. So first I will arrange the term of sin x. So what will be the coefficient for sin x? It will be a into 1 a minus 2b, b into minus 2, so minus 2b. So a minus 2b, a minus 2b sin x. Then what is the coefficient of cos x? Cos x will be 2a plus b, 2a plus b cos x plus, now next it will be a 3a plus c, so 3a plus c, this is a constant term. Now if we compare with the left hand side, we can see there is no sin x in the left hand side. So therefore the coefficient of sin x in RHS, that is a minus 2b, will be 0, and the coefficient of cos x will be equals to 3. So therefore 2a plus b will be 3, and 3a plus c will become 2. Now if we solve this equation, so first of all I will take these two equations and solve it. We will get some value of a and b. So we are getting a is equals to 6 by 5 and b equals to 3 by 5, and using the value of a we can put here and we can get the value of c, and the value of c is minus 8 by 5. So that means I will first replace the values. So a will be equals to 6 by 5, b will be equals to 3 by 5, and c will be equals to minus 8 by 5. So therefore cos x plus 2, this 3 cos x plus 2, this 3 cos x plus 2 will be 6 by 5 into this plus 3 by 5 into this minus 8 by 5. We can see that the integral is changed, that numerator is changed like this. Now after that I will distribute the denominator. So if I distribute, first of all it will be 1, so dx, 6 by 5 integration dx. Then it will be f dash x by fx, so 3 by 5 f dash x by fx, and with the constant term nothing to do, minus 8 by 5 dx by this. Now in this kind of thing, again we need to apply the first method, because we can see in the numerator there is 1. So for that first method, so for this integration we can directly write it is log mod fx. So here fx will be sin x plus 2 cos x plus 3. This will be 6 by 5 x. So these two integration done. Now this integration. So for this kind of integration we have to write sin x as 2 tan x by 2 by 1 plus tan square x by 2, cos x as 1 minus tan square x by 2 by 1 plus tan square x by 2. Now after that we need to do the LCM. So if I do the LCM, it will be 2 tan x by 2 plus 2 into 1 minus tan square x by 2, so 2 minus 2 tan square x by 2, then plus 3 into 1 plus tan square x by 2, so 3 plus 3 tan square x by 2, 3 plus 3 tan square x by 2, and in the denominator it will be 1 plus tan square x by 2, which will go in the numerator. So therefore this will be secant square x by 2, and we have to write this thing as simplify this thing. So if I simplify, it will be 5 plus 2 tan x by 2 plus tan square x by 2. Now there is a secant square x by 2. We know if I take tan x by 2 as z, so we need to adjust here 1/2. So let me adjust a half here. So if I adjust a half, we need to multiply 2. So it will be 8 by 5 will become 16 by 5. Then it will be 4 plus 1 plus 2 tan x by 2 plus tan square x by 2. Now 5 can be written as 4 plus 1. So that 1 will be added with these two terms. So it will become 1 plus 2 tan x by 2 plus tan square x by 2, and it will become 1 plus tan x by 2 whole square. And there is a 4, this that 4 will become 2 square. So now if I take tan x by 2 as z, which I have not taken here, I have done directly, but you have to take common, you have to do it and do this thing. So therefore if I take tan x by 2 as z, half secant square x by 2 dx will become dz, and this will become 2 square plus z square. So therefore it is dz by a square plus z square. So what is the integration? Dz by a square plus z square, it is 1 by a tan inverse z by a. So here a is 2, so 1 by 2 tan inverse, and z is this entire thing, 1 plus tan x by z is this thing, tan x by 2. So tan x by 2 plus 1, tan x by 2 plus 1 by a. Z is tan x by 2 plus 1, so this by a. So tan inverse of tan x by 2 plus 1 by a, and we have to write all these things plus c. So this kind of integrations are very methodical integrations. Here you no need to apply heavy thinking. You just follow the methods and you can solve it. but for that you need to practice more and more sums. So that's all for today, and in my next video I will talk about integration by partial fraction. So bye for now. Thank you.